All right, great. All right, thank you guys. So like they said, I'm going to be talking about testing types. So I think this is maybe the third talk today that's had the definitely typed GitHub slide up. So I'm going to be talking about definitely typed again. So just sort of show of hands, how many people have installed like an @types module or pulled code down? Yeah, so basically everyone. How many people have run into a bug in a type declaration file from? Yeah, okay, quite a few. How many people have contributed a fix for a bug? Okay. And how many people have written a test for? Okay, a lot fewer. All right, so I'm gonna try to convince you guys today that writing tests for type declarations is really important for us to do, and also kind of tricky to do correctly. And I think there's some traps that are easy to fall into that I'm gonna try to show you how to avoid. So just the numbers on this are kind of insane. I think Anders talked about this already. Yeah, so what I'm gonna focus on is the high quality part of definitely typed, because it's the repository for high quality TypeScript definitions. So, what makes a type definition high quality? So I think the sort of a useful mental frame for this is the uncanny valley. So this is something that usually gets talked about with robotics. So Masahiro Mori proposed this in 1970, that as you're building a robot, as it becomes increasingly human-like, as you go from this industrial robot arm to something that looks more like a person, it starts to become more likable. But then, as you get kind of close to something that looks like a human, but noticeably different, it actually becomes really creepy. So here's Wally. Wally is somewhat human-like, but clearly not a human. No one's going to get confused. And Wally is very, very likable. So here's Anders. I think Anders is human, probably not a robot. Could maybe be convinced otherwise, but he seems pretty likable. But then in this sort of middle ground, you get these kind of weird things that are a little hard to look at. So I'm not going to dwell on that slide. So I think this is a good mental model when you think about increasing the type safety of your program. So there's sort of this curve, as type safety increases. Initially, as you start to get some types, I think your developer happiness generally goes up. But I think there is sort of this valley, right? So on the left here, we have JavaScript, right? So JavaScript, there's no static types. You know that there's no static types, and so you always need to be thinking about what the type of a variable is. You need to be looking at it at runtime, and you need to be kind of on guard about things that could go wrong. But you know what you don't know, right? And that's kind of the important thing. And then on the other end, there's TypeScript with accurate types, right? So TypeScript will keep track of the types of symbols for you. And what's great about this is that you can trust the types, and you don't need to keep track of that all in your memory, right? TypeScript can keep track of it for you. You can kind of let your guard down. You don't have to worry as much. But then I think somewhere along the spectrum, we have TypeScript with not really accurate types. And I think this is super dangerous because as you get more type safety, you start to let your guard down a little bit. You start to trust the type system. And if the type system isn't right, then you can wind up in a situation where you think you know what the type of a variable is, but it's actually wrong. And you wind up having to both fight against the compiler, but then also keep track of what the real type is in your memory. And so I think the important thing here is that I think in that valley, having bad types is actually worse than having no types at all. And so we want to try to avoid that. So here's just some examples of things that can go wrong, right? So this process row, we've declared that it's mapping strings to numbers, but then actually I lied. There's actually this one key name where the value is actually a string. And so if you're using this type, you need to constantly be doing these assertions, as unknown as string, and you need to be doing these checks. And you also need to remember that, this type actually isn't correct. Or with a network request, right? If the declared type is foo response, but we know it's actually a bar, this is hard to keep track of, and it generates a lot more code. And I think this is actually even more important for @types files, right? Because in most cases, in most projects, the majority of your code is actually going to be third-party code. And if the type declarations for third-party code aren't right, then that makes the whole experience of using TypeScript worse for everyone who uses those modules, right? So here's just an example from like the underscore library. I don't want to pick on underscore, but this type happens to come out wrong, right? And if you're new to TypeScript and you install the @types and something comes out wrong, you don't necessarily know that it's the type declarations that's wrong. You might think you're doing something wrong. You might think that TypeScript just isn't capable of keeping track of these types. And so I think for sort of the TypeScript experts in the room, like this is a really important point of like very high leverage for the entire TypeScript community, right? Having good type declarations improves the experience of using TypeScript for absolutely everyone. Yeah, so here's just one more example of a type not coming out correctly, and you need to do a type assertion. All right, so high quality. What makes what makes code high quality? So usually the answer is testing, right? It's not sure if your code was good or the tests were really lousy. So it's possible to do tests well, and it's possible to do tests poorly. So I want to look at a couple different ways of doing that with types. And just to sort of step back a second, like why do we write tests, right? And I think most people immediately think of this first one, right, to ensure program correctness, to ensure that your code actually does what you claim it does. But there's some other reasons that I think are important too. Right? They make your expectations explicit about what the code's behavior is. And that's important because the next person who changes that code might not be you, right? It might be a coworker, it might be you in like a year when you've totally forgotten all the context of why you wrote the code this way now. So it helps you maintain expected behavior in the future. So sometimes people use this phrase programming in the future tense. I think it also helps, writing unit tests also helps with reviewing code, right? I think it's a lot easier to understand the implementation of a piece of code if you've seen the expected usage of it first. So when you're doing a code review, you can look at the unit tests for a function before you read the implementation of a function, and it might make more sense. And I think Josh referenced this earlier. I'm also a big fan of TDD. So testing enables test-driven development, right? So this is where you write your test first, and of course there's no implementation of the feature, so all your tests are going to fail. And then you implement the feature and slowly turn all the tests green. And the nice thing about this, other than the fact that you wind up with a test, is that you've encoded your expectations about behavior before you implement the function. And I think that's important because you're writing down your expectations of how it's going to work before you sort of know the expedient way to implement it, right? You've written the test from this perspective of a user of the function. So let's look at writing some tests for type declarations. So this is just the ordinary ES5 array map method. This is the TypeScript type declaration for it. So just to reiterate this, we're talking about testing the types. We're not talking about testing the implementation, right? So we're not going to test that, if you call map on an array of numbers and square them all, that you're going to get the squares back. Like we assume that V8 or whatever JavaScript engine you're running has already written implementation tests. So we're specifically talking about tests for the type declarations. So this is the corresponding underscore map function. You don't really need to read this. Just my point is that it's not trivial. So here's one way to write a test for a map function. So you can just call the function and check that there's no TypeScript errors, right? And I think this is pretty appealing because oftentimes you can just take your own code that uses this function and drop it into a test, and that's all you have to do, right? So does this work? I think maybe it's a little too early in the talk for the answer to be yes. So yeah, it sort of works, right? So you'll catch pretty egregious errors with this, right? Like if you declared map to take the wrong number of parameters, then you would get an error for that. But there's sort of something missing here, right? So I think Josh also did this pattern of looking at something in type in the world of types, and then also looking at it, what the equivalent would be in JavaScript. So I'm going to do that here as well. So, so here's a function square. It squares a number, and then here's my test for it, right? So I'm trying to cover the whole domain. So I've got a negative number. I've got 0. You should always test 0. I'm scoring 10. I'm scoring something that's not an integer. So a great test, right? But there's something kind of missing here, right? The problem is that you're not actually asserting anything, right? You're checking that square doesn't throw any exceptions, but you're not actually checking what it returns, right? So you really want to do something more like this. You call the function and you check what the return type or what the return value is. So that sort of suggests that we need to do something with the return values of these functions that we're testing. So this is a slight improvement, right? So we can create a variable and we can declare a type on it and then assign it to the result of map. And so now we're actually getting our first test failure here, right? So this map expression, this converts an array of numbers into an array of strings, but we've declared that it's an array of numbers, and that's wrong. So we're actually getting an error. So this is good. The test can fail with type errors. So you can also, if you don't like those unused variables, you can also wrap this up with a function and a generic type. It's the same thing. So does this approach work? Same thing. It's an improvement, but it has some problems. And so one of them has to do with structural typing. Right? This is one of the core ideas of how types and assignability work in TypeScript. So here I have this room type. So a room has an area in square feet. It has a height. And I have this function getKitchen that's going to, I want to assert that getKitchen is going to return something of the room type. And this function, you can call this function, and this test passes. It's great. But there's an elephant in the room, right? And it seems like maybe we should be aware that the elephant is in the room, right? So this works because the thing that getKitchen returns does have an area in square feet, and it does have a height in square feet. So it's assignable to the room type. The fact that there's an elephant in the room is kind of irrelevant from an assignability point of view, but probably from testing this function, that's something you care about and you should be checking for. So the important thing to remember here is that assignability, it's not testing for equality. Assignability is more like a subset relationship. So I think this can come up in a lot of ways, but particularly for function types, this can get really confusing because you have to think about the parameters and the return type. One of them's covariant, one of them's contravariant, and I can never remember which way it goes. So this sort of suggests maybe a way we can make this a little fancier. So in math, if you have two sets, if you have A and B, and A is a subset of B, and B is a subset of A, then that means that A is equal to B, right? So maybe that's also true in TypeScript. If A is assignable to B and B is assignable to A, then maybe A is equal to B, right? And so maybe we can turn that into an even more clever type assertion. So I think this is something you also see in the wild. So we have one of these conditional types that we've been seeing today. So we're checking that the type T extends the type U, and then we're also checking that the type U extends the type T. So it goes both ways. And we actually are getting an error here for this kitchen example, right? Because it has an extra property. So the assignability works one way, but not the other. The error message here isn't great, but maybe at least this is checking what we want. This also sort of works. There's kind of two interesting reasons that this doesn't entirely work. So one of them is a little complicated and subtle, which has to do with how conditional types distribute over unions. I'm not going to get into that. But the other one is a really big glaring problem, which is the any type, right? So any is the opaque type in TypeScript. It basically disables the type checker, and any is assignable to any other type, and any other type is assignable to any. So if you have an any type in your type declaration, then this sort of assignability check is just going to pass, even if you don't want it to. So this is kind of a problem. And I think, thinking about this in terms of the uncanny valley of type safety, any types are kind of a really fast track down into this valley of, unhappy unproductivity with the type system, right? Some people, if you're familiar with floating points, they call them the nan of the type, the nan of the type system, because anything you do with any, if you call an any type, if you access a property on an any type, you're going to get an any type back out, right? So they kind of spread. And this, I think in the context of type declarations, this is also particularly problematic because even if you have no implicit any set in your own project, if your type declaration has an any type in it, if the @types module has an any type in it, then you never type the word any, but you still have these any types like creeping into your program and spreading through your code. Or if you use one of these declare module statements, maybe you're just too lazy to write type declarations, then the entire module gets an any type, right? And so you can import anything you want from it, and any function you call from it or class you create from it also gets an any type. So, so this is something we need to watch out for. This is a real problem. I just ran some stats the other day, and of all the packages on definitely typed, a majority of them have at least one any type. Not every use of any is bad, but that at least suggests that this is a problem. 17% of them had 10 or more any types. Okay, so that was a bunch of stuff that didn't work. So so how should you test types for definitely typed? So I think the right way to think about this is, when you're writing a type declaration in your editor, how would you test it, right? You probably call the function, and you mouse over it, and you look at the type that comes back up in the hover text, right? And so I think the right way to test type declarations is to do exactly that, right? So that's what dtslint does. So this is what a dtslint test looks like. So you include this special comment at the end of your expression, $expect type, and then it does a string comparison on the types, right? So here, the string type is, quote, ANY, and the type it's comparing against is the string regexp. You can also, so if you run this through dtslint, it will say it expected the type to be regex, but it was actually any. And it doesn't matter that any is assignable to regexp and regexp is assignable to any. The string versions of the types are different, and so they're different. You can also put expect type in, you can put it in a bunch of places. So here I'm calling the map function, and Typescript, using the type declarations for map, is able to infer the type of the callback parameters. And so I can assert that those have the types that I expect, which if you're using a library like Lodash, this is actually a really important part of the experience. And so it's important to be able to test that these have the expected type. This is my favorite JavaScript joke. So some programs set the type of this for their callbacks as part of their API. And so if they do that, TypeScript lets you declare the type of this in a callback. And so you should test that, right? So the way to do that with dtslint is you create a callback, and you just put the word this, and you assert its type. And here, this is jQuery, but you can see that this is getting set to an HTML element. You can also assert that errors happen, right? So this is sort of a negative assertion. So in this case, this is also jQuery. The second parameter of this data method, it can't be undefined, and so they assert that an error happens if you try to pass in something that might be undefined. So same question as before, does this work? I mean, yeah, I think so. You're maybe going to get, so string comparison of types is a little bit blunt, right? It might make distinctions that aren't meaningful, right? So A union B and B union A, those are the same type. dtslint is going to draw a distinction between those, which is maybe a little bit annoying. But those are all kind of false positives. It's going to err on the side of failing. It's not going to have false negatives in the way that some of these other approaches based on assignability are going to have. So sort of in a slightly different context, shameless plug, I wrote a book, so it's called Effective Typescript. It's coming out next month. If you want a discount code, ask me afterwards. But most of this is a specific item in the book. So writing a book about a programming language is kind of terrifying, right? Because it's very easy to make mistakes. And writing a book about TypeScript is particularly terrifying because the language is changing every 3 months. They're coming out with new versions. And so each of those has the potential to make something in the book obsolete. So it occurred to me that it would be very much in the spirit of TypeScript to do some sort of like type checking on the book itself. So I don't know how well you guys can read this here, but this is a bit about the differences between type aliases and interfaces, the differences are getting increasingly murky over the years. But I wrote out this whole paragraph about how interfaces can be recursive in ways that type aliases cannot. And so I had this example here of how you can't create a recursive type alias. And the way you annotate that you mark errors is you have these squiggles and comments, and then you say what the error message is. And that's the thing that gets verified. So TypeScript 3.7 beta came out a few weeks ago, and so I installed it, and I ran the checker, and I got this error. So expected TypeScript error was not produced. Type circularly references itself. So I was claiming that an error happens if you do this, and it didn't happen. So then I looked at the release notes, and sure enough, Anders implemented recursive type references, so I just deleted that whole thing. So there's also expect type. So the way I wound up doing this is in a comment, you start the comment with type is, and that actually gets checked by this verifier. So here I'm talking about how you can sometimes subtract types, but only if it winds up being an actual type that's representable in TypeScript. And so I'm pointing out that you can subtract string or number from string or date, and get a type back, but you can't subtract 0 from number because non-zero number is not something that you can really express in TypeScript right now. And so I ran the type checker over this, and it said that the expected type of the symbol t was number, or I expected it to be number, but actually it was date. And if you read it, that's actually correct. So this is a typo in my code. It should say type is number. So of the, I think, like 6 or 7 technical reviewers who read the book, only one of them noticed that. So I think the machine is doing pretty well here. So this is called literate TS, if you want to check it out. It has fewer contributors than definitely typed. Okay, so how are we doing? So this is a chart I made of the number of packages on definitely typed that have a dtslint assertion, so expect type or expect error. There are around 6,000 packages total on definitely typed, so it's a minority, but it's definitely increasing over time. I'm not quite sure what that spike at the end of 2018 is. Maybe some of the TypeScript people know. But it's definitely going up, and the total number of type assertions is going up over time as well. So that's good. But when I think this actually, there's pretty real, tangible experience of using the language, ways that this comes out. So while I was preparing this talk, I found this sample file I had made back in June of 2017 of all these expressions I was trying to do with underscore that just didn't come out with the right type. And so this was one of the things that inspired me to get interested in testing types in the first place. And so I thought it'd be fun to go back and run these all through Lodash now and see how many of them come out with the correct type. And it's literally every single one. So that's pretty exciting. Even kind of complicated things come out with precisely the right types. So I think there has been a lot of very tangible progress made in testing type declarations over the last few years. And so I'm excited to see that keep going. So yeah, if you're writing type declarations, write tests for them. Remember that if you're using assignability for testing types, there's some potential problems with that, so be careful about it, and maybe consider just using something like dtslint. And also just be conscious about producing incorrect types because those can make the TypeScript experience worse for everyone. So thank you guys. I think we've maybe got time for some questions.
Yeah, we've got some questions.
Thanks. So do you think there's any value in using something like dtslint on the actual source code itself, like doing type level checking, or do you think that just kind of implicitly gets picked up through the implementation tests?
Yeah, I think, well, so I think the value is if you're shipping a library that does something interesting with the type system and you want people using your library in TypeScript to have a good type level experience, then yeah, I think there is value. I think dtslint is mostly used for testing stuff on definitely typed, but there are some other tools, like I think TSD is one of them, that are designed more for testing the types in your own code. So that's probably a good one to check out as well. But yeah, I think there's absolutely value if you expect other people to be using the types of your code.
So since for unions the type order is not necessarily guaranteed, don't you get a lot of false positives when doing just string comparisons for unions?
I think you can. I think well, maybe the TypeScript people would know better if there's any sort of determinism to the order in which they come out. No? Okay. Yeah, I think it's a problem.
There's sort of
partial determinism. There you go. I noticed Anders did make a change to dtslint to allow you to specify multiple possibilities. So you can specify A union B or B union A. But yeah, that's probably something to improve the experience around.
Great talk. Can you think of ways in which the TypeScript team can encourage more people to do this indefinitely typed?
Well, I know you guys have lots of spare time reviewing definitely typed pull requests, so yeah, I mean, I guess personally, I always find like code coverage tools to be a good motivator to like try to increase the number. Somehow that feels like more motivating than just writing types in a test in a vacuum. So maybe like type code coverage percentage could be a useful thing to track. Yeah.
So you said testing two-way assignability is not quite sufficient, but you could also test with never and unknown and detect any's pretty easily, couldn't you?
I think detecting an any type in the type system itself is surprisingly tricky. Maybe other people can correct me if I'm wrong, but I think it's always a little scary to try to do tests for equality within the type system, since TypeScript is so much of it is based around structural typing, which is more of a subtype relationship. So yeah, I guess maybe you could get that to work, but I'd just be very cautious about that.
I had experiences with coworkers not knowing that having functionality in the comments is a valid thing, and that they would remove comments and things like that. Is there any other API other than using the comments to assert these kind of types?
Yeah, so I guess that is an issue with dtslint. So another way that can come up is if you misspell expect type or well, I guess if you misspell expect error, you'll probably notice that because you'll get an error. But if you misspell expect type, you just won't be doing the type assertion and you'll think it's passing. So yeah, that's a problem. I guess maybe a type test code coverage tool could help you catch that sort of thing too. All right. Great. Thank you, guys.